Good day everyone. For today's report is all about solid state relay. So the first discussion is what is a solid state relay? So solid state relay is an integrated contactless electronic switch device that is compactly assembled from integrated circuit and discrete components. Depending on the switching characteristic of the electronic components such as switching transistor, bidirectional thyristors, and other semiconductor components. The SSR are able to switch on and off state of the loads very quickly through the electronic circuit, just like the function of traditional mechanical relays. Compared with the previous coil-reed contact relay, namely electromechanical relay or EMR, there is no movable mechanical part inside the SSR, and there is also no mechanical action during the switching process of the SSR. Therefore, the solid-state relay is also called non-contact switch. So now let's proceed to the next slide. So the structural characteristic of the SSR switch make it superior to the EMR, which is electromechanical relay. The main advantages of the solid state relays are as follows. So the first one is a semiconductor component act as a switch for the relay, which is small size, which is the compact size, and long in life, which is a long lifetime. Second is better electromagnetic compatibility than EMR, immunity to radio frequency interference or RFI, and electromagnetic interference which is EMI, and low electromagnetic interference and low electromagnetic radiation. So third is no moving part, no mechanical wear, no action noise, no mechanical failure, and high reliability. Fourth is no spark, no arc, no burning, no contact bounce, and no wear between contacts. Fifth is with zero voltage switching, zero current shutdown function. Easy to achieve zero voltage switching. Sixth is fast switching speed. SSR switching speed is 100 times higher than general EMR and high operating frequency. 7 is high sensitivity, low electrical level control signal, and SSR can directly drive large current load through the small current control signals. Compatibility with logic circuit, which is TTL, CMOS, DTL, HTL circuits. Easy to complement multiple functions. And lastly, generally packaged by insulation material with good moisture resistance, mildew resistant, corrosion resistance, vibration resistant, mechanical shock resistance, and explosion proof performance. So these are the main advantages of solid state relay. So the next slide will be solid state relay versus electromechanical relay. So the amplification and drive function of the solid state relay is very suitable for driving high power actuator, which is more reliable than electromagnetic relays. The control switches of solid state relay require very low power, so the low control currents can be used to control high load currents. And the solid state relay uses mature and reliable opto-electronic isolation technology between the input and the output terminals. So this technology allows the output signal of the low power devices to be directly connected to the input control terminals of the solid state relay. To control the high power device of the output terminal of the solid state relay without the need for additional protection circuitry to protect the weak current device, because the small control current device, which is connected to the SSR input terminal, and the large control power supplies, which is connected to the SSR output terminal, have been electrically isolated. So this technology allows the output signal of the low power device to be directly connected to the input control terminals of the solid state relay to control the high power device at the output terminal of the solid state relay without the need for additional protection circuitry to protect the weak current device, because the small control current device, which is connected to the SSR input terminal, and the large control power supplies, which is connected to SSR output terminal, have been electrically isolated. Besides, AC solid-state relay use the zero-crossing detector technology to safely apply the AC SSR to the computer's output interface without causing a serious interference or even serious failure to the computer. And this feature cannot be implemented by EMR, only implemented by SSR or solid-state relay. And because of the inherent characteristic of solid-state relay, And the above advantage SSR has been widely used in various fields since it came out in 1974 and has completely replaced electromagnetic relays in many fields where electromagnetic relays cannot apply, especially in the computer automatic control system field because the solid state relay requires very low drive power and are compatible with the logic circuit and can also directly drive output circuit without the need for an additional intermediate digital buffer. These are the application of solid-state relay. So solid-state relay perform well in military, chemical, industrial automation, control devices, electromobile, telecommunication, and civil electronic control equipment, security and instrumentation application, which is electric furnace heating system, computer numerical control machine, which is a CNC machine, remote control machinery, solenoid valve, medical equipment, lighting control system, home appliances, office equipment, fire safety systems, and electric vehicle charging system. And also, solid state relays has disadvantages, which is first one is exists on state voltage drop and output leakage current. Second is need heat dissipation measures. Third is higher purchase cost than EMR. Fourth is DC relays and AC relays are not universal. Fifth is single control state. Sixth is small number of contact groups. And lastly is poor overload capability. And now let's proceed to the second discussion, which is what is the structure of solid state relays. So the solid state relays are 4 terminals active devices. 2 of the 4 terminals are input control terminals and the other 2 terminals are output control terminals. Structures are similar and consist mainly of 3 parts, which is input circuit, which is the control circuit, drive circuit, and output circuit, which is the controlled circuit. So the first part is input circuits, or also called a control circuit. Provides a loop for the input control signal and making the control signal as a trigger source for the solid state relay. So according to the different input voltage type, the input circuit can be divided into 3 types, which is DC input circuit, AC input circuit, and AC-DC input circuit. And the DC input circuit can be further divided into resistive input circuit and constant current input circuit. So, the resistive input circuit whose input current increases linearly with increasing input voltage and vice versa. So, if the control signal has a fixed voltage or control voltage, the resistor input circuit should be selected. And next is the constant current input circuit. When the input voltage of the constant current input circuit reaches the certain value, the current will no longer increase obviously as the voltage increases. So this feature allows the use of a constant current input solid state relay over a fairly wide input voltage range. And solid state relay can be easily connected to TTL circuit, which is transistor logic circuit, and CMOS circuit, which is a complementary metal oxide semiconductor circuit. And next is DTL circuit, which is a diode transistor logic circuits, and HTL circuit, which is the high threshold logic circuits. At present, TTL has been gradually replaced by TTL and HTL has been replaced by CMOS, and if the pulse width modulated signal or PWM is used as input signal. And the on and off switching frequency of the AC load supply should be set as less than 10 Hz, or the output switching rate of the output circuit of the AC SSR cannot keep up with it. And so the next part is drive circuit. So the driving circuit of solid state relay includes 3 parts, which is isolation coupling circuit, function circuit, and trigger circuit. So however, according to the actual needs of solid state relay, only 1 or 2 of these parts may be included. So isolated coupling circuit, or the isolation and coupling method for input and output circuit of solid state relay currently use 2 ways, which is optocoupler circuits and high frequency transformer circuit. So optocoupler, are also called photocoupler or optical coupler or opto-isolator, is opacally packaged with an infrared LED and an optical sensor to achieve isolated control between the control side and load side, because there is no electrical connection or physical connection between the light emitter and the light sensor, except the beam. And next is the high frequency transformer coupling circuit, uses as a high frequency transformer to convert the control signal at the input to the drive signal at the output. So the detailed process is the input control signal produce a self-isolating high-frequency signal that will be transmitted through the transformer occurred to the transformer secondary, and after the process by the detection or the rectification circuit and the logic circuit, the signal will eventually become the drive signal to drive the trigger circuit. Second is the functional circuit. So the functional circuit may include various functional circuits such as detection circuit, rectifier circuit, zero crossing circuit, acceleration circuit, protection circuit, and display circuit. Third is the trigger circuit. So the trigger circuit is used to provide a trigger signal to the output circuit. So now let's proceed to the last part, which is the output circuit. So the output circuit of the solid state relay is controlled by a trigger signal to enable on and off switching of the load power supplies. So the output circuit is mainly composed of an output component or chip, an absorption loop which act as a transient suppressor, and sometimes include the feedback circuit up to now. And the output component of solid-state relay mainly include bipolar junction transistor or BJT, which divided in two types, PNP and NPN. And second is thyristor or silicon control rectifier or SCR. And triac, which is bidirectional triode, bidirectional thyristor, bidirectional control rectifier or BCR. Next is metal oxide semiconductor field effect transistor or MOSFET. And next is insulated gate bipolar transistor, which is IGBT. And lastly, silicon carbide MOSFET or SiC MOSFET, which is a kind of wide bandgap transistor with the industrial grade highest operating junction temperature of 200 Celsius, lower power consumption, and compact size. And also, output circuit of the solid-state relay can be divided also into three types, which is DC output circuit, AC output circuit, and AC-DC output circuit. So the DC output circuit typically uses bipolar components such as IGBT or MOSFET or MOSFET as the output component. And the AC output circuit usually uses two thyristor or one triac as the output component. And that is the structure of solid-state relay.
What is the symbol of solid-state relays? So, the symbol of solid-state relay in the circuit schematic is shown below. So, this is the solid-state relay circuit. And the electrode symbol should be marked separately inside or outside the frame next to each pin of the graphic symbol. Input terminals and output terminals cannot usually be drawn on the same side of or adjacent sides. And when multiple solid-state relays appear in the same circuit diagram, a numeric number can be added after the text symbol to distinguish the relays. So the SSR1 and SSR2. So let's move to the number 4. What are the types of solid-state relays? So the types of solid-state relays are various and classification standard are multivarious. The solid-state relays are usually classified according to the following criteria. So this is the type of solid-state relays. The load power supply type. The type of load power supply is the DC SSR, AC SSR, and control trigger mode. And the type of the control trigger mode is zero crossing AC solid-state relays, random turn-on type AC solid-state relays, peak turn-on type AC solid-state relays, and the other is the type of the power supply, load power supply is the phase, and the type of phase is single phase AC solid-state relays, three-phase AC solid-state relays, and the other type of load power supply type is switch component. And The other type of the solid state relays is the input and output form, switch type, and the isolation coupling. And the type of isolation coupling is the reed relay coupling SSR, transformer coupling SSR, photocoupling SSR, hybrid solid state relay. And number 5 is a circuit structure, performance, mounting, and application. So that is the types of solid state relays. So the load power supply type is the solid state relay can be divided into DC solid state relays, the DC SSR, and AC solid state relays is the AC SSR according to the type of the load power supply. So the DC type solid state relays use the power semiconductor transistors as the switching element, such as BJT, MOSFET, IGBT, to control the on and off state of the DC load power supply. And the AC type solid state relays use the thyristors, such as triac, SCR, as the switching element to control the on and off state of the AC load power supply. So this is the load power supply type, the DC-SSR. So based on the input form, DC type SSR can be divided into resistive input type DC solid state relays and the constant current input type of DC solid state relays, as I mentioned in the load power supply type. And the other one is AC SSR. The AC type SSR can be classified according to the following standards. And control trigger mode. According to the control trigger mode, the timing off, turn on and turn off. So the AC SSR can be divided into zero crossing type AC solid state relays, random turn type AC solid state relays, random turn type AC solid state relays, and peak turn on type AC solid state relays. So what is the zero crossing AC solid state relays? These are also known as zero crossing trigger AC solid state relay, zero crossing turn on solid state relay, zero switching AC solid state relays, zero voltage AC solid state relays, or synchronous AC solid state relays. For the zero crossing SSR relays, their switching state of the output circuit are synchronized with the output signal, and that is synchronous to the power supply. So when the input signal turned on, if the load supply voltage is in the non-zero crossing zone, the output terminal of the zero crossing type solid state relays will not be switched on. But if the load supply voltage reaches zero zone, the output terminal of zero crossing SSR relay will be switched on, as well as the load circuit will be turned on. This trigger mode can effectively reduce the inrush current generated during SSR turn on, and also reduce the interference signal to the power grid and the input control circuit at the same time. In consequence, the zero crossing solid state relays are the most common type in many fields. So this is the figure of the internal structure schematic and the input and output waveform. And random turn on type AC solid state relays, so are also known as random switching AC solid state relays. Random switch on the AC solid state relay, random conduction AC solid state relay, random fire AC solid state relay, instantaneous turn on solid state relay, non-zero switching AC solid state relays, instant on AC solid state relays, instantaneous AC solid state relays, asynchronous AC solid state relays or phase modulation AC solid state relays. So the output circuit switching mode of the random type SSR relay is controlled only by the control signal, and it's independent of the power supply signal, the asynchronous with the power supply. Random type solid state relays will be immediately turned on as long as there are input signal in the input terminals, and regardless of the state of the load voltage, since random solid state relay is turned on or off at any phase of the AC power source, a large interference signal may be generated at the turn on instant. So this is the figure 4.3 of the random turn on type AC solid state relay. So next is peak turn on type AC solid state relay, are also known as a peak switching AC solid state relay or peak far AC solid state relays. When the input control signal is applied, the peak type SSR relays are turned on at the first voltage peak point of the AC output voltage to reduce the inrush current. If the input control signal is removed, the peak solid state relays will be turned off. So the next is phase. According to the phase of the AC supply, the AC SSR can be divided into the single phase AC solid state relays and the three phase AC solid state relays. So this is the single phase AC solid state relays. Based on the different function of the single phase AC solid state relays can be divided can be further divided into single phase AC and DC solid state relays, single phase solid state voltage regulators, and single phase solid state governors, one open and one closed single phase solid state relays, single phase forward and reverse solid state relays, single phase dual solid state relays, and so on. So it should be mentioned that the dual relay in the figure 4.4, so which is the kind single phase solid state relay that combines two single phase industrial solid state relays into one standard industrial package with double input terminals and double output terminals, and each set of input and output terminals is independent of the other set. That is, the dual SSR relays have more contacts and can achieve more diverse control than the normal types. So next is the three-phase AC solid state relays can be directly used for the control of three-phase AC motors, and the three-phase forward reverse AC solid state relay or three-phase reversible AC solid state relay can be used to control the three-phase forward reverse motors. That is a three-phase bidirectional AC motors or three-phase birotational AC motors. So next is the switch component. According to switch components, the ACSR can be divided into the ordinary type AC solid state relays and the enhanced type solid state relays. The ordinary type SSR relays use the triac as output switching component, and the enhanced type SSR relays use the SCR anti-parallel as the switching component. So next is the input and output form. According to the input and output form, the solid state relays can be divided to four types. So these are the four types that can be divided. The DC input AC output type solid state relays, and that is the DC and AC SSR relays, DC input DC output type solid relays, and AC input and AC output type solid state relays, AC input, DC output type solid state relays. So that is the input and output form. And next is the switch type. So the switch type is, according to the switch type, the SSR switches can be divided into normally open type solid state relays or normally SSRS, NO SSRS, and normally closed type solid state relays or NC SSRS. So the normally open solid state relays will be turned on only when the input terminals are applied with the control signal. On the contrary, the normally closed solid state relays will be turned off when the input signal is applied to the input terminal unless otherwise specified. The solid state relays in this document refer to normally open solid state relays by default. So number 4, isolation coupling. Isolation and coupling. According to isolation and coupling methods, the SSR can be divided into red relay coupled type solid state relays, transformer coupled type solid state relays, photo coupled type solid state relays, and hybrid type solid state relays. So this is the figure of the isolation and coupling methods. So the read relay coupling SSR, as we can see in the figure 4.5, uses read switch as the isolation methods. When the control signal is applied directly or through the preamplifier to the coil of the read delay, the read switch will be closed at once and the thyristor switch will be activated to make the load conduct. So next is a transformer couplings SSR. As you can see the figure 4.5, the letter E. So it uses a transformer as an isolation device. The transformer can convert to low power control signal from the primary coil to the secondary coil to generate a signal for driving the electronic switch. And if the input control signal is a DC voltage, a DC and AC converter is required in the input circuit. So after processing by rectification, amplification, or other modification, the signal from the secondary coil can be used to drive the switching component. And next, the photo coupling SSR, as we can see in the figure 4.5, the letter C. The letter C in this figure, the letter C. Also known as photo-isolated SSR or opto-coupled SSR, uses an optical coupler as an isolator. So the optical coupler is an opto-isolator that consists of an infrared source, usually a light-emitting diode or LED. So and a photosensitive semiconductor component such as a photosensitive diode, a photosensitive transistor, and a photosensitive thyristor. So according to the different components, the figure 4.6, the optocoupler can be into optodiode coupler, photodiode coupler, or to the optotransistor coupler, the opto-SCR coupler, and the optotriac coupler. So you can see in the figure 4.6, in the first one is the optodiode, and the second one optotransistor, and the next one opto-SCR, and the last is the optotriac. So the photosemiconductor device detects the infrared radiation from the LED and then produce a signal to drive the semiconductor switch. Compared with read relay and transformer, the optical isolator has better physical isolation ability to ensure the electrical isolation between high voltage output load circuit and low voltage input signal circuit. and on account of the excellent isolation performance and very compact size of the optocoupler. The optocoupler solid-state relay is used in a very wide range of applications. So next is the hybrid solid-state relay. It is a special solid-state relay which combines the advantage of EMR and SSR with high efficiency and low power consumption. So the input and output circuit of the hybrid solid-state relay are composed of an SSR relay and a reed switcher or a microelectromagnetic relay in a parallel controlled by different control signals as we can see in the figure 4.7. So when input signal 1 is applied, the SSR immediately switches to the on state. Since the electronic switch has no moving parts, it can switch the load stably and quickly and does not generate an arc due to high line voltage or heavy surge current during switching. After the load current is generated, the EMR will be controlled by the control signal 2 and the switch on. Because the EMR is connected in parallel with the SSR, the output contact of the EMR is energized without voltage and there is no R-sync across the contacts. Then after the certain delay, the contact bouncing of the EMR settles down and the SSR will be turned off. The EMR works also with no heat, so the hybrid SSR relays can be run without a heat sink installed. As you can see in the 4.8, the electromechanical relay. And next is the 5, circuit structure. According to different circuit structure, the solid-state relay can be divided into discrete structure type solid-state relays and hybrid structure type solid-state relays. So the discrete structure solid-state relays are mostly assembled by discrete components and printed circuit board, and then packaged by epoxy resin coating plastic sealing or resin wrapping. The hybrid structure solid-state relays use thick film combined technology to assemble discrete components and semiconductor integrated circuits, the IC, in short IC, and then encapsulate them in a metal or a ceramic housing. So number 6, the performance. According to the performance, the solid-state relay can be divided into the standard type solid-state relays and the industrial type solid-state relays. So the rated current of the standard solid-state relay is generally 10A to 120A, and the rated current of the industrial solid-state relay is relatively large, can be 60A to 2000A or larger. Therefore, the industrial SSR relay can meet the strict requirements to the industrial environment and industrial machinery. So next is mounting. According to the mounting methods, the solid-state relays can be divided into panel mounting type solid-state relays or surface mounting type, day and rail mounting type solid-state relays, and printed circuit board mounting type solid-state relays or PCB mounting type. And the PCB mounting SSR can be further divided into socket mounting type SSR or plug-in mounting type, and the bracket mounting type SSR or flange mounting type. The plug-in solid-state relays with many package standards like SIP, mini SIP, and DIP can be directly soldered on the printed circuit board, relying on natural cooling without the need for a heat sink. The flange mounting solid-state relays require the additional metal plate or heat sink to dissipate heat. So the last one is application. According to the application, solid-state relays can be divided into general application solid-state relays, two-way transmission solid-state relays, automotive solid-state relays, latching solid-state relays. The input signal runs as a logical exclusive, or 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 XOR. So many input can latch or unlatch the output. and so on. So the latching relay can keep conducting the continuously output the control signal even if cutting off the control current, and it can only be turned off by inputting the reverse current of the or the off button. So the latching is usually used in high voltage circuit to avoid the expansion of accident.
What are the basic parameters of solid state relay? So basic parameter of solid state relay falls into three categories. First category is input parameter, second is output parameter, third is other parameter. Input voltage range or input current. The input voltage range refers to the voltage that range value that must be input, either minimum or allowable input, either maximum for the solid state relay to operate normally when the ambient temperatures is at 25 degrees Celsius. So turn on voltage or turn off voltage. Turn on voltage when the input voltage is the applied input terminal is greater than or equal than to turn on voltage. The output terminal will be turned on. Turn off voltage or when the input voltage applied to the input terminal is less than or equal the shutdown voltage. The output terminal will be turned off. Zero crossing voltage. Strictly speaking, the zero crossing voltage is not a voltage point but a voltage range that determined by the terminal component of the zero crossing relay. Output parameters. Rate output voltage or rate operating current. Output voltage is the highest load operating voltage that the output terminal can withstand. Rate operating current is the maximum steady state operating current that can be passed through the output terminals and the ambient temperatures of 25 degrees Celsius. So the output voltage drop or output leakage current is the measured output voltage at the rate operating current when the solid state relay is on the state. Output leakage currents refer to the measured currents values that flowing through the load under condition that can be solid state relay is in the off state. So inrush current also known as overload current, input to surge current, or switch on current refers to the non-repetitive maximum current value to the divide with not be parameter damage, and the output terminal can be withstand when the solid state relay is on the state. Other parameters is the power consumption. Power consumption refer the power voltage consumed by the solid state relay itself, the power state, the power on and off. Switching on times or switching time. Switching on time is the time it takes for normal open solid state relay to start from the beginning applied to input control voltage until the output terminals begin to switch on and the output voltage reaches 90% of the final variation. Switching of time is the time it takes for the normally open solid state relay to start from the beginning cutoff the input control voltage until the output terminal begins switch off and the output voltage reaches to 90% of the terminal variation. Insulation resistance or dielectric strength. Insulation resistance refers to the measured resistance value between the input terminal and the output terminal of the solid state relay. When a certain DC voltage from the example of 550 voltage is applied It can also include a measured resistance value between the input terminals and the outer chassis, including the heatsink, and a measured resistance value between the output terminal and the housing. Dielectric strength or dielectric withstand voltage refers to the maximum voltage value that can be tolerated between the input terminals and the output terminals of the solid-state relay. It can also include the maximum voltage that can be tolerated between the output terminals and the housing, and maximum voltage that can be tolerated between the input terminal and the outer chassis. Operating temperature, maximum junction temperature. Operating temperature refers to the normal working environment temperatures range allowed when the solid-state relay installs the heatsink according to the specification, or when the heatsink is not installed. The junction temperature, or short for transistor junction temperature, is the actual operating temperature of semiconductor in the electronic device. In operation, it is usually higher than the case temperature and the external temperature of the component. The maximum junction temperature is the highest junction temperature allowed by the output switching component. So, what is the working principle of solid-state relay? The internal equivalent of circuit diagrams of ordinary solid-state relay is shown in the figure 6.1 below. The principle solid-state relay can be simply described as the for no SSR, when the appropriate control signal is applied at the input terminal in of the solid-state relay, the output terminal out will be the switch from the state to the on state. If the control signal is cancelled, the output terminal out will be restored to the off state. In this process, the solid-state relay realized non-contract control of switching state of the load power supply, which is connected to out terminals. It should be noted that the input terminal can be only connected to the control signal, and the load should only connected to the output circuit. DC solid-state relay whose control signal voltage input from the input terminal IN, and the control signal coupled to receive the circuit to the photocouple, and eventually the signal is applied by the applier to drive the switching state of the transistor. Obviously, the output terminal or out of the DC solid state is divided into positive terminal plus pole and negative terminal pole. Be careful not be mistaken when connecting output terminal DC SSR relay to the control circuit. DC solid state relay use the control of the on-off state and the AC load circuit. Unlike a DC solid state relay, the SSR relay use the bidirectional transistor or triac or other AC electronic switching component. Therefore, there is no positive and negative terminal in the output terminal or out of the solid state relay. The working principle of zero crossing AC solid state relay. So, zero crossing AC solid state relay are complier and more typical than other types of solid state relays. The operation details of AC zero crossing SSR relay can be illustrate complete working principle of SSR relay. As the function A and E are to E circuit in the block diagram form the body, the zero crossing ECSSR. On the whole, the SSR relay is the 4-terminal load which switch only 2 input terminals 3 and 4 and 2 output terminals is 1 and 2. In the EC0 crossing, SSR relay is working as long as the certain control signal is added to 3 and 4 terminals. The on and off state of the load that between 1 and 2 terminal can be controlled. So this is the diagram of the function each component. The A is a coupling circuit, B is a trigger circuit, C is a zero crossing detector circuit, and D is switching circuit. And next I'm going to snubber circuit and to the load. The process working when the optocoupler or OPT is turned off. Either the control terminals of OPT has no input signal. A1 is the saturated and turn on obtained the base of the from R2, and the result of the gate trigger is UTG of the transistor SSR is complete come to the low potential and turn off. Sequentially, the triac BCR is in the off state relay. Off state because there is no trigger pulse on the gate control terminal R6. When an input control signals apart on the input terminal of the solid state relay, the photoresistor or OPT is turned on. Either the control terminals of OPT has an input signals. After the power main voltage is the voltage divided by the R3 R2. If the voltage of point A is larger than the zero crossing voltage of M1, either VA is greater or less than VBE1, M1 will be in the saturated conducting state, and both SCR and BCR transistor will be in the off state. If the voltage at the point of A less than the zero crossing voltage of M1, either VA is greater than BVE1, M1 will be in the cut-off state and the SCR will be triggered to the conduct, and the trigger pulse from the R5 UR to SCR to UR to R6 direction or the opposite direction is obtained on the control pole to the BCR to active BCR, and final load will be connected to AC main. Definition of zero crossing. Here it need explain that with the zero crossing, the alternating current of the zero crossing of the instantaneous point, which is there is no voltage present, that is at the junction between the positive half cycle and the negative half cycle of the AC waveform. In each cycle alternating current, there will usually be two zero crossing, and if the power main switch at the instant point of zero crossing, no electrical interference will be generated. The AC solid state relay equipped with a zero crossing control circuit will be on state, and when the input terminal is connected, the control signal and the output EC voltage rose 0. Conversely, when the control signal is turned off, the SSR be in the off state until the next 0 crossing. In addition, it should be the point of out on the 0 crossing of solid state relay. Does not actually mean the 0 volt of the power supply voltage waveform. So region 1 is the dead region, cut off region, cut out region. Or turn off region will be absolute value of the voltage range of 0 to U1, and in this zone the SSR switch cannot be turned on even an input signal is added. The region 2, the response region, active region, cut off region, and cut in region, on turn on region with the absolute value of voltage range of U1 to U2. In this zone, the SSR is immediately turned on as soon as the input signals is added, and the output supply voltage increases. So region 3 is the suppressor region, saturation region, with an absolute value of voltage greater than U2. And in this region, the switches element of tie resistor is the saturated state, and the output voltage of the solid state relay will no longer in the increase with the increases of the power supply voltage, but the current increases with increasing voltage, which can be regarded as a terminal short circuit. I/O waveform from the 0 crossing solid state relay, and because of the natural resistor at the solid state relay will be in the state after the voltage of terminal reaching the threshold voltage. For the trigger voltage of the trigger circuit, then the solid state relay will be the actual on the state after reaching the saturation voltage, and the same time generate a very low on state voltage drop.
Current signals to control high power equipment such as electric motors, pulse valves, and other machinery. As an electronic switching element without mechanical contacts, solid state relays are widely used in a remote control system with excellent advantages: flexible control, high reliability, high durability, no spark, no noise, fast switching, high operating frequency, and strong anti-interference ability, and etc. Lighting control system. The fast switching, long life, and high reliability of solid state relays make themselves excellent in the light control system. In the field of traffic lights, the working environment of traffic lights is complicated, but in solid state relays with excellent characteristics, moisture-proof, explosion-proof, anti-corrosion can face it. The third is the heating cooling equipment. Normally, there are 3 ways to control the heating cooling equipment: solid state relays, SSR, transistor module, SCR module, and AC contactor. Currently, solid state relays and SCR modules are very common in cooling heating equipment, but in the contrast, SCR modules are not cost effective. So solid-state relays are most common in heating, cooling equipment, such as electric ovens, coffee machines, vending machines, griddles, fryers, and air conditioner, refrigerator, and etc. Computer numerical control machinery. Many traditional mechanical relays in computer numerical control machinery, CNC machine, are gradually being replaced by the solid-state relays. On account of the excellent durability and high sensitivity abilities, the solid-state relays are applied to ensure the high precision and high quality of CNC machine. In the servo system of CNC machine, the solid-state relay can receive the control signal continuously and control the processing machine accurately. Electric vehicles. Solid-state vehicles are widely applied in the field of electric vehicles. For example, the explosion-proof solid-state relays are used in fuel cell vehicles. To avoid the electric arcs and incorrect operation during vibration, as well as each high-voltage power unit is protected by the combination of multiple solid-state relays, fuses, and filters capacitors. Medical devices. In the field of medical equipment, the equipment has strict requires of operating frequency and precise operation. So the components of medical equipment should have nice performance, high precision, durability, and etc. Solid-state relays can meet these demands of medical devices. For example, the infrared radiation devices are huge thermal inertia, but by connecting the solid relays to the radiation plate, it becomes very easy to control the temperature of infrared radiation device through the solid-state relays. Computer control system. The computer control system, including the computer, peripheral devices, have high requirements of relays. But types of various of solid-state relays can help the computer devices control sorted power unit to drive the large mechanical automation equipment or hydraulic and pneumatic equipment, because solid-state relays have the characteristic zero crossing, nice electromagnetic compatibility, and high sensitivity, fast switching speed, low level control signal, compatible with logic circuit, which is a TTL, CMOS, DTL, HTL, and even can be directly connected to the microcomputer control device, and so on. And the lastly is the chemical and mining industry. Considering the complex of working conditions and special requirements, the explosion-proof, moisture-proof, and anti-corrosion abilities of the chemical and mining industry, the traditional mechanical relays cannot meet such requirements. Therefore, lots of solid-state relays are used to intermediate the controllers of the major mechanical equipment, such as the solid-state relays equipped in large coal mining elevators. How to select the solid-state relays? The following are options to consider when selecting the appropriate solid relays based on the actual requirements. The first is the load voltage, AC or DC. The first consideration is whether the load voltage is AC or DC to determine whether AC SSR or DC SSR is selected. Secondly, the voltage of the load power supply should be considered, which cannot be larger than the output rating voltage and less than minimum voltage of the solid relays. Then, consider the magnitude of the load voltage and the transient voltage. RC circuit. RC circuit, also known as RC filter, RC snubber, or RC network, is a circuit consisting of the resistor and the capacitor. It is recommended to select solid relays with a varistor absorption circuit and the RC snubber circuit. The RC circuit blocks certain frequencies from passing and allows other frequency signals to pass to filter out the interfering signals. Load current, maximum current, and minimum current. The output current value of solid state relays is steady state current following through the output terminals of SSR, which is usually equal to the current of the load connected to the SSR output terminal. Since the switching elements of the SSR switches are very sensitive to temperature, and the overcurrent can generate a high amount of heat, so the overload capability of SSR is weak. Load type: resistive, inductive, or capacitive. Resistive load, the loads can divide it into three types based on electrical impedance. Resistive load type or pure resistive load, inductive load type, and capacitive load type. There is no pure conductive and inductive load and pure capacitive load in the usual electrical appliances, because these two type loads don't active power in the serial parallel circuit. If capacitive reactance is larger than the inductive reactance, the circuit is capacitive load, and vice versa. Inductive load. Generally speaking, the inductive load is the load that applies the principle of electromagnetic induction with inductance parameters such as high power electrical products like refrigerator, air conditioner, and etc. The inductive load will increase the power factor of the circuit, and the currents through the inductive load cannot abrupt change. At start, the inductive load requires much larger starting current, approximately 3 to 7 times, than the current required to maintain the normal operation. Capacitive load. Generally, a load with a capacitance parameter is called the capacitive load, and the capacitive load will reduce the power factor of the circuit. During charging or discharging, the capacitive load is equivalent to a short because the voltage across the capacitor cannot be changed abruptly. Input control signal, AC to DC. First, input control voltage. The input control voltage has a wide range of 3 to 32 volts. Second is the input control current. The input current of DC SSRS and AC single phase SSRS is generally around 10 milliamps, and the input of current of AC three-phase SSRS is generally around 30 milliamps, which also can be customized to be less than 15 milliamps. The third is the control frequency. In the control frequency of AC solid state relays generally does not exceed 10 Hz, and the DC solid state relays control period should be greater than 5 times than the sum of relays on time and off time. Mounting method: PCB panel or DIN rail mounting. In many cases, the load power will limit whether the SSR is mounted on the PCB, the panel, or the DIN rail. Ambient temperature for calculating the liberating factor of the size of heatsink. Ambient temperature is when the relay is on state, it will withstand the dissipation. Ambient temperature. When the relay is on the state, it will withstand the dissipated power of P is equals to V. On the state voltage of voltage drops times 1 load current, and the load capacity of the SSR is greatly affected by the ambient temperature and its own temperature. If the ambient temperature is too high, the load capacity of the SSR will inevitably decrease accordingly. Moreover, the SSR switch may be out of control or even be permanently damaged. There are two ways to use the rating factor. First is the rated current value of the solid state relay can be selected accordingly to the rating factor of different environments and in different load types. The rated current of the SSR relays is equal to the continuous current value of the load divided by the rating factor. The second is if the solid state relay has been selected and the load type of environment changes, the load current should be adjusted based on the load curve and the rating factor in certain environment. The adjusted current multiplied by the rating factor must be lower than the rated value of the solid state relay.
Attention when using or installing solid-state relays. So, when we say attention, the first thing that would sing in our mind kay to be attentive. Why? Because for safety. So, this following attention below is for a safety of using or installing solid-state relays. The actual application condition of the product must fully comply with the requirements of the parameter and characteristic curves of solid-state relays. So, we should strictly have to follow the parameters o characteristic of actual application condition of the product because it's really the first thing to do to avoid future problems. Second, na mga butang na dili compatible so it's really necessary nga kung unsay angay sa iyaha or nibagay nga para sa iyaha mao jud dapat tumanon. Second, SSR should not be used in application with a large number of low or high harmonic components. For example, multiple set of loads at the output of the inverter need to be switched separately. So, since there's a big possibility na mag-overheat, nga mag-cause din og pag-explode. The third, the SSR relays should be keep away from the strong electromagnetic interference source and RF interference sources to ensure that the SSR can operate stably and safely, avoiding loss of control. So, it is necessary jud kay para ma-sure nato nga safe and stable ang atong SSR, di siya mag-interrupt. So, unsa man na ang electromagnetic interference? Mao ni siya atong ginagamit para sa communication networks like satellite, radio, TV. 4. Except for the solid state relay with rated current of 1.5A, which can be directly mounted on the printed circuit board. The other solid-state relay should be equipped with appropriate heatsink. So, we must prioritize and make sure that the thermal grease should be applied between SSR base plate and the heatsink screwed tight to make them close to each other for optimum heat dissipation. Number 5. When the input voltage of the input control signal is too high and exceed the rated parameter of the SSR, the input resistor can be connected in series to the input circuit to reduce the excess value. The control signal and the load power supply need to be stable and the fluctuation should not exceed 10%. Otherwise, the voltage regulation measures should be taken. So, take note, and be reminded of the voltage regulation measures. 7. If using solid-state relay to control the primary circuit of the transformer, the influence of the transit voltage of the secondary circuit of the primary circuit should be considered. So, the primary circuit should be considered since the transformer may also generate surge currents. Number 8. The output of the solid-state relay is not completely insulated when load power is applied to the output terminals. Even if the solid-state relay does not operate, there will be some leakage current at the output terminals, which should be noted when using and designing the circuit. So, we should keep to be reminded that even ang SSR kay wa nag-operate na ay uban leakage current sa output terminal. And during sa maintenance, we should cut off the power supply before mag-proceed to check the output circuit. Number 9. When a solid-state relay needs to be replaced due to a fault, the SSR relay with the same model or technical parameters is recommended to match the original application circuit and ensure reliable operation of the system. Having the SSR relay with the same model or technical parameter is highly recommended jud. Di lang to have a compatible result para ma-match ang orig na pag-apply sa circuit nga reliable operation sa system. Attention when testing solid-state relays. First, the relationship between the output current and the shell temperature should be known before testing to avoid permanent damage to the SSR caused by overload, because the rated output current will drop when the case temperature rises or with no radiator. So, checking first the relationship between the output current and shell temperature para maiwasan ang grabe nga damage sa SSR kay due sa pag-overload. Number 2. When testing the turn on and turn off voltage of DC SSR, the input voltage cannot remain in the state between on and off for too long. Otherwise, the power consumption of the output terminal rises sharply and burns out the output switching components. So, if we testing the turn on and turn off, di jud dapat magstay sa on and off for too long kay it burns out, mag-overheat o mag-overload, so unsa may resulta? Useless. Number 3. Do not arbitrarily speed up the action rate during the test. Usually, one pair of the input signal should be more than 5 times the sum of the on-off times. Otherwise, the SSR relay will not work due to the large dynamic switching loss, or even the output switching components will be burnt out. So, this is not to arbitrarily speed up the action rate during test for reason na ay possibility nga dili na mag-work ang SSR. So, unsay man na ang arbitrary speed, random choice of speed, dili measured, so out of parameter nga speed. Number 4. The solid-state relays cannot achieve complete isolation between the output terminals in the off state and there will be a certain leakage current at the output terminal. When the dielectric withstand voltage and insulation resistance are tested at a higher voltage, it is prone of electric shock. So, the insulation resistance or the withstand voltage must not be tested on the output terminals. So, solid state relays cannot be achieved complete isolation sa output terminals sa off state and naay leakage current sa output terminal. So, in this state, it is really prone to have an electric shock. So, the necessary thing to do is dapat itis ang ECSR sa output terminals.